So conservation of momentum is a principle that works only when there is no external force. If there is no external force, the total momentum of a system, I will tell you what the system is. Total momentum of a system is always conserved. So the system could be two or more cars. So let's say a car is traveling to the right at some momentum. Let's call that car A. This is the initial momentum of car A. And let's say another car, call that car B, moving to the left. It has momentum of PIB, or sometimes it's written PAI. Okay, I'll just use the notation that is used in the book. So PAI, PBI. Okay, so they collide at some point. So they collide, and then they may either move away from each other. This is case 1. Or case 2, they may get stuck and move together as a single object. So that's A, that's B. So they may move either to the right or to the left, okay, with some common velocity. So PB final. Okay, so these two cars comprise the system. So in this case, there is no external force acting on the car. We are assuming that there is no friction. Okay, so assume no friction, and they are colliding with each other without any other external force acting on them. So there is no force. This is before collision. And this is after collision. So there is no external force. So total momentum before collision should be equal to the total momentum after collision. And this principle will not work if there is friction or some other external force. It works only when there is no friction or external force. Okay, so if I want to write this in terms of formula, so total momentum before collision is momentum of A plus momentum of B. So that's the total momentum of the system. And total momentum before is denoted by I. Okay, so that's equal to total momentum after collision. Again, our system is A and B, so momentum of A plus momentum of B. For the after collision, we'll use momentum final, momentum of B final. Okay, so if I want to further simplify this, so momentum of A, formula for momentum is m times v. So m times v, m times v, m times v, that's the formula for momentum. Here we are dealing with A, so mass of A. Here it's B, mass of B, mass of A, mass of B, velocity of A. So this is momentum of B, so velocity of B, velocity of A, velocity of B. Also, this left part is before collision, so before collision is I, initial, and the right side is after collision, so final. And I don't need to write F and I for mass because mass is conserved, mass doesn't change. So that's the conservation of momentum. Now I gave you two cases here after the collision. One is bouncing away from each other, other one is sticking together. So in both cases this formula works. Okay, so this works for both case 1 and case 2, as long as no external force acting on them. So this kind of collision where they bounce back is called elastic collision. And this kind of collision where they get stuck and move as a single system or single object is called inelastic collision. So the difference between elastic and inelastic is, in case of elastic collision, kinetic energy is conserved, and in inelastic collision, kinetic energy is not conserved, meaning some of the energy in this case is lost in form of heat or sound, whereas in case of elastic collision all the energy is conserved.